Michael Chin, and I'm the Principal Facade Engineering Lead for Arup Singapore. I'll talk a bit about Arup very quickly. We are a global company, 88 offices around the world in 33 countries. Our revenue is over in excess of 1.7 billion, and we've been operating for 70 years. In fact, this is actually our 70 years anniversary. And we've got 15,000 staff and counting. Arup is multidisciplinary, and by that I mean we've got essentially all the core services as well as the specialist services. These are just some of them. And in Singapore, we've got about 400 people in the Singapore office. This is a quote by Old Arup. I'd like to start with that. He always encompassed or espoused the principle of total engineering, right? And even back in the 1970s, when he did his key speech, he's already talking about total engineering, and that's how we want to design, whatever buildings that we are involved in. So essentially, when he said that, when engineers and quantity surveyors discuss aesthetics, architects study cranes, what cranes do, then we are on the right track. So the principle of total engineering is not new, right? And this is what in Arup we like to call the approach. That's our approach to design, and we kind of start off with the basic needs, and that's what you imagine a building, that would be the enclosure, the structure, and then as you go higher, the performance, the functionality, and then we talk about the building performance. All right. In today's context, we are talking about U value of glass, SC of glass, and what are the different components and how do they perform. Then aesthetic and image. Obviously now, with many buildings trying to achieve more and more ambitious design, and eventually we as engineers we try to get all of them together and hopefully achieve what we call holistic design. Right. At the top, we call it utopia, but very often, how to achieve that, is an issue. And in today's context, that's where digitalization or digital tools have become an enabler, especially for us engineers. So this is just one of the workflow that we use. All the different software, different logos they're looking at, from actually doing the structural analysis to looking at geometry. And then facade optimization, your thermal performance, and then on the right hand side you've got your documentation, right? Revit, AutoCAD, something that we're very familiar with, and of course now we are even talking about visualization and virtual reality and all that. So without tools, without software, without digital, that's a bit hard to establish. Although the thinking has been there for quite a while. So today I will talk about 3 topics actually that we have been working on at Arup. First one is facade canvas. Second one is actually how we solve complex design issues, mainly our geometry and modulation studies. And of course, the last one is digital inspections. So facade canvas is an in-house tool that we developed, right? And it's essentially our definition of parametric design exploration. Right? We do exploration from time to time, and we what we call optioneering, day in, day out, and in what is the quickest way to do it. We want to do it as efficient as possible, because this process essentially a circular process that go round and round until you get a solution that you want. And in the olden days, we kind of look at things in 2D, right? And obviously architects has their drawings, their elevations, their GAs, and of course when it comes to a different consultant, the structural engineers has one set of drawings. The facade engineer, at that time we don't even have facade engineers. He will be looking at his set of drawings in that sense, and all of that becomes a bit hard to really understand, and also capture. Especially when you want to do design, it becomes even more difficult. So now, with software, we are looking at single source of truth, right? We are looking at one model. Daniel talked about BIM and all that, and it's so common now But essentially, for us facade engineers, we want it even more important that we do options, again and again. And now we're even incorporating structural engineering tools into the software and what we call facade canvas. And what comes out at the end of it, to the client and architect is something that is easily understood, something that has already gone through the structural engineering rigors, and essentially you can incorporate things like performance, thermal performance, acoustics, and even in today's context, carbon. All that you need is actually a script. So we are developing libraries, look at how we categorize the different facade systems. And within all of these systems will be quite familiar to you. And essentially, it's very often that, for, let's say, for example, curtain wall, right? We look at different options. So you got one option, you move the spandrel up, in one option. The other ones, you increase the vision panels, you move the sunshades up and down. When we were doing AutoCAD, that was kind of quite a difficult process. Although, we can imagine it, but we don't really know how to convey that. So essentially using the software, and this is built into a series of Rhino and Grasshopper scripts, we can quite easily get all of these things done very quickly. So any options that you want to change, right, within the parameters of this design, you can, right? And essentially all of these are just with a few clicks, and essentially we get the different options. And similarly, this one here, in the case of refurbishment, we can also do the same thing, easily looking at essentially looking at parametric design in a very quick and easy manner. Right, all of that is done in a software, in a tool that we can eventually add on more and more scripts, at the end of the day, to make our life and design process a lot easier. About geometry a little bit, this is also something that we do quite a bit, and you will be quite familiar with this structure, jewel. And we kind of look at it this way, the end product, it's pretty complicated. How do you actually get to that? I would say without any 3D tools and software, and the methodology that we go about getting to whatever it is now, you will never be able to get something built, in that shape or form. And essentially, kind of start with this. And of course, architect has his renders, and the competition is won. The architects and its early consultants. Design stage, will essentially work out some of these inputs, right? And essentially it goes around a few parameters, right? So this is something on plan, this is something on elevation, but essentially there are a few points that the design or the design concept has been given to us. You've got a point at first story, you've got the points at the ring beam, which is on the 5th floor. And then you've got a top, what we call a point on the roof. And at the end of it, you've got the point at the end of the curve, call it the curve. And that's where, after this, the water flow will start to come down. And how do we actually get from here, or, the way to actually all of these parameters and build it into a shape, that can be buildable. And it's not, if you look at it, it's a series of arc curve, with a certain radius, and comes to a certain point, it's actually spline curve, and when you say spline means it's essentially connecting the points, two or three points together, the best curve that you can, doesn't confine to a specific radius, right? And using, again, scripting Rhino and Grasshopper, and we had to look at what is the existing geometry. There's a model that was provided. And essentially, we're going to look at a gradient at every point. And when you look at it, when you smoothen it, and basically what we will come up with is, when we actually build it, to get to a structure, you need to have all the different elements. You can imagine all of these are segmented glass. And eventually what will happen is, every one of that piece needs to be quite smooth. And that's the reason why you can't conform to a specific geometry in that sense, right? It all depends on requirements or building requirements to actually form the shape that you want. So eventually going through this process, essentially build the curve, that curve, the curvature or that model, what we call surface regeneration, through this process, so that you can get almost a smooth kind of surface around the entire structure, right? And then once that is done, essentially you call that modulation or the geometry is done, then you start looking at different options. All of this may look alike, but they are slightly different, right? And that's where you essentially look at things, what we call horizontals and the number of panels, and that actually led to the maximum glass size. Every one of them has slightly different modulation in that sense, which is leading to different sizes and different quantities for different things, right? So without software, without digital, no way, we can actually get all of these things out. Of course, you can do it by hand, but that will be painstaking, right? It is a drone view, and essentially, when you look at it, it's 4 towers, and they're all connected by this so-called sun shading element that goes round. And the design intent was just a series of curves like that, and it's different on every level. And frankly, it's a series of spline curves, and it doesn't make quite a lot of sense in that sense if you start looking at it, because every piece, you look at the one on the left, every piece of that is one different color, right? And one different color is one different size. Every floor is 2,300 panels, thereabouts. And you can imagine, if you're going to build that, a contractor is going to build that, it's going to run into big problems, and of course, big costs. Every piece is different. So you run through it with a series of scripting. Again, it goes to the left, the right option. You kind of relax, what we call a dynamic relaxation, and you put it within certain boundaries, using a script. And essentially, you can then kind of smoothen the curve a little bit, and bring down your panels, to smaller and to more regular repetitions. Frankly, you can't tell at the end of the day. So there are things like that, ETTV calculations, which are very familiar to you. BMU, BMU is always an issue. I won't talk about that today, but that's we've always done BMU in 2D, right? Maintenance, and that's always an issue, right? People can't imagine, where would this gondola and how is it going to be this area, how is it going to be maintained, by the BMU, and all of that done in 3D actually makes it a lot easier. ETTV is the same thing, agree. It's no longer a regular shaped building, right? Where we can just use a spreadsheet and do our ETTV. Nowadays, all the buildings are curved, facing different direction, and by using a script, you can easily get the ETTV out quite quickly. The thing is, what are facade inspections and how typically how we have done it in the past, right? And you imagine, how can you actually do that? Previously you go down to the gondola, a guy, the inspector, has his 2D drawing, 2D markup drawings, and then you go down every floor, you inspect, and then you try to mark it up on the elevation if there are issues, and you're kind of depending on one inspector doing it all right? And he's the eyes and the ears, and he basically tried to do quite a few things at the same time, and of course he's up there hanging out in the air. And then at the end of the day, you can imagine all of this data being compiled in piles and piles. It's not easy, and it's very time consuming. One building full inspection the last time around, medium size, probably take us 6 to 9 months to actually do a full inspections, right? That is definitely too much time, and not very efficient and not very accurate, right? So then Arup will start to kind of look at it and see how can we kind of streamline this workflow, right? We call it digital workflow. And we started looking at that model preparation. Is there something we can do on that front? And then after that we start looking at every stage of our inspection process to actually make it smarter and make it more efficient, right? So it runs across model preparation, coding and programming, and of course inspection, the physical inspections. We've obviously got human still hanging there outside in a gondola, but we also start using drones and all these tools to actually help us. And of course the final one is report writing, and that's a part where don't underestimate your piles and piles of data, how to make sure that you're accurate and those numbers are accurately captured, right? So I'll start with the model preparation. And of course, you've got a building, you've got an as-built drawings, it's easy. And we kind of built a Revit kind of model, similar to a Revit model, and we built it from scratch. And we essentially built a model pretty quickly using the as-built drawings. But sometimes your existing buildings they don't have as-built, right? Because they're quite old. And that's where some of the problem lies. And we've actually got to use tools, like the metaboard scanner, and also some of the drone scanning devices that we have to actually build the surfaces from ground zero. And so essentially build a model just based on the sort of scanners that we have in the market. And using that, we then this is kind of like the existing Matterport scanner, the LiDAR scanner on the internal front. For clear spaces like that, you can actually get quite good model, and it's quite accurate. Then after that, we start. That's the difficult part. Essentially, when we build a model, it's kind of like a surface model. When we have a Revit model, we actually need to link each and every one of the images or the drone images to the element or to that model. So we know exactly where the elements, where the defective elements are. And the whole kind of process is built around this. You've got 10, for example, your whole drone come up and down, or your human going up and down, right? You collected 10,000 photographs, for example, and how to link them, where previously you were do, mark it up on your 2D elevations. Now you actually immediately mark it on your model itself, using either the drone images or the human, essentially holding, for example, an iPad or Android device, which is linked to that model. So it's a lot more accurate, and the data is stored immediately. There's no difficulty, in kind of no inefficiencies to retrieve sort of like the files later. The last part that I was talking about was the report writing. Again, all of this can then be generated into reports quite easily. And a lot of these reports essentially, because they're inspection reports, so there's quite a lot of repeats, and the format, as you can see on the right, for example, when you're doing inspections, all the inspections are done, identified by the point of inspections, and then it goes straight into a report in a report format. Right, so there's very little things that we need to add on, except maybe the executive summary at the front and of course the summary at the back. The best thing about it is we can get data out of it. We know how many defects that we can that the building has, and then we can do charts like that, which essentially means that it's a lot more interactive. A person looking at it will know, oh, from this elevation it seems like the southeast elevation, the northeast elevation seems to have a lot more defects compared to the other three elevations, and then this data can be communicated more effectively in that sense. I think that's my last slide, and essentially this is the first project in Arup, right? And of Arup's first project is actually the penguin pool in the London Zoo. Kind of the first project that was built quite closely together with the architects and the contractors, using expressive and structural precast concrete. And during those times, it's really quite special, to have a structure just based on concrete like that. It's thin and very expressive. And that process, he's attributed it to the whole process of total design. That he's thinking, back in the 1970s and even earlier, even at that time, always think of design as total design, right? Rather than every single different disciplines working together, to produce a product. So I think my last point is we have all the digital tools that we have, but they are all enabler. Right? The main thing is don't lose sight of the design itself. It's all to help us deliver a better design at the end of the day. Okay, I think that's the end of my presentation. Thank you very much.